Okay, so today's speaker is Julia Goldstein. Her presentation is Greening Semiconductor Manufacturing, and it's a great pleasure to introduce Julia. Julia is a classmate of mine from college. I won't disclose how long ago that was in deference to Julia, but she's a friend, and very much look forward to having her present. She started her career as a process development engineer in semiconductor packaging before she moved to journalism. After her stint in the corporate world, she was the technical editor of the Advanced Packaging magazine, and at the same time served on the MEPTEC advisory board for several years. She later covered the printed electronics industry, and she started her own technical writing and communication firm in 2011. So she is an author for hire, but bringing her extensive technical background into her work. One of the things that drove this presentation is her book, Material Value, let me get this right, Material Value, More Sustainable, Less Wasteful Manufacturing of Everything from Cell Phones to Cleaning Products. So she does have some of those here, and would be more than happy not to take those home. So if you'd like a copy, you can purchase that from her. She'll autograph that. Or if you want to bring over your Kindle, I'm sure she'll sign her name on the front of your Kindle or your iPad with her Sharpie. So, anyhow. So with that, I'd like to welcome Julia. Thank you.
All right, thank you, Ira. Hi, I'm glad to be here. As Ira said, I'm going to be talking about greening semiconductor manufacturing. For decades, we've been hearing the story about how we have to make electronics smaller, faster, and cheaper, right? I think probably the very first article that I wrote back in the mid-90s about semiconductor packaging, I talked about that in the introduction. We've got to be chasing Moore's law, and now more than more, and make vertical integration so that we can pack more and more and more power and more computing power into a smaller footprint and make it as cheaply as possible. But have you thought about making it cleaner and greener? Not everybody is thinking about this, but a lot of folks are. And today, I'm going to help answer the question, why should you care? And I'm going to talk about who's on board, taking a look at what companies are being leaders in making their manufacturing processes sustainable and responsible. I'm going to talk about aspects to consider in your own manufacturing firm. And then take a look up and down the supply chain, because it's not just what happens in your factory, but you've got to look at the entire process of the life cycle of your products. And I'll finish by giving you some resources and suggest some next steps that you can take. So why should you care? Well, the climate is changing. We've seen catastrophic fires, floods, hurricanes, and it's only going to get worse unless we do something about it. And we know that greenhouse gas emissions from burning fossil fuels are to blame for this problem. So if we take a look here, I gotta get the right thing there. Okay, we've got some data here from 2017. If I do that like that, yeah, there we go. So if we take a look at industry here, that's a significant fraction of it. And that's all types of different manufacturing, but semiconductor manufacturing and semiconductor packaging is certainly a part of that. But the semiconductor manufacturing process also makes contributions to transportation, right? You've got to get your parts and your products shipped around the world to customers. And electricity. You need electricity to run your factories and your buildings. So when we take a look at the greenhouse gas emissions, they're divided into three different scopes. Scope 1 is the stuff associated with your manufacturing process in buildings with equipment that you own. Scope 2 has to do with purchased energy. You need to buy energy from the grid that's often made from fossil fuels, natural gas, coal. It can be from renewable sources, but that's the source of scope 2 emissions. And then scope 3 looks at the supply chain. What are the emissions involved in making the chemicals and materials and parts that you buy? What are the emissions that happen after the product leaves your factory, when it goes to your customer, and then to your customer's customer, and then is eventually disposed of in some manner? So all those aspects are part of this. But now I want to go back in time a little bit, probably a lot. I'll give people a little bit of clue, maybe how far back we're talking. Back to Mr. Riley's 5th and 6th grade classroom. And Mr. Riley, he really believed in innovative teaching. We had a small class, just 18 students, and we got to do some really cool stuff. So I remember this one project where we were designing a concept of a space station. Now, it didn't look anything like the International Space Station photo that I have here. We had a concept where we had this kind of central area, which was sort of like the center of a city, and then it had all these spokes, like 8 spokes coming out. And at the end of each would be kind of like a little village where people would live. And one of the projects that I ended up doing, we made a big paper mache model of this thing. It was like, 3 or 4 feet across. But one of the other things is I wrote a letter to some imaginary member of Congress or somebody in the federal government saying, we need trees on our space station. And I was explaining, because the trees need to soak up the carbon dioxide that the people breathe out and provide oxygen. And I don't know where trees were going to get their sunlight in this space station, but whatever. I probably didn't think about this. In any case, I decided we had to have trees, and I wrote this letter saying, here's why we need funding for trees. Another thing that happened in Mr. Riley's class was he took us on field trips. And this was before we had seatbelt laws in California. And so he would pack all 18 students into his VW bus. And then one of the things is our elementary school had a contest every year to see which classroom could collect the most aluminum cans. Because I don't know if you remember back, soda cans used to be steel long, long ago. But then they were starting to switch to aluminum, and so they wanted to encourage recycling. Mr. Riley would take us all on a field trip to the beach, and we'd have these big plastic bags, big giant like black plastic bag trash cans, and we'd collect aluminum cans. And guess what? His class won the competition every single year. So I'm not just telling you this because it's amusing or entertaining. There's a reason it's related, because of the energy cost of materials. It doesn't cost just money. It costs energy to dig ores out of the ground. Mining, oh my goodness, the amount of waste and toxins and everything in mining, I don't need to go all into that, but you probably have a little bit of a concept of it. If you look at the energy cost to produce a ton of different types of materials, then you'll understand why aluminum is the most recycled metal, why gold is so expensive, and why silicon is pretty dang expensive too. So I'm going to show you a graph here. So this graph, I want you to point out here, on this axis we got a logarithmic scale, because otherwise we can't show everything. So we take a look at lumber over here. That's only 2.5 gigajoules per ton, because it doesn't take that much. You just got to cut down trees, right? But if you want to make that lumber into paper, then you're talking like 10 times as much, right? Here's paper, right? 10 times as much, because that's actually kind of a dirty industry. When you've got to do all the pulping, there's a lot of chemicals involved, there's a lot of energy that takes. But then when we go to metals, it's much greater. And here's where you can see the difference between aluminum. This is aluminum where you're mining it from bauxite ore, or recycled aluminum. And you can see it's a big difference. And then you look at gold up there at 53,000. And the reason it takes so much energy to mine a ton of gold is because it's available in such little infinitesimal amounts in the ore. There's data from Barrick Gold Corporation that says it takes anywhere between 2 and 90 tons of ore to get 1 ounce of gold. Yes. So that's part of why gold is so expensive. So silver is a little more plentiful than gold, so it's not so expensive. But look at what's second most. Silicon wafers, 20,000. There's a boule out there. Did you see that in the lobby of Semi? And it talks a little bit about that. So you're starting from silica sand and ending up with a silicon wafer. You've got a long, expensive process that takes a lot of energy. So that's why I get especially passionate about the materials aspect of environmental causes. I got a degree, advanced degrees in material science back when. And I didn't used to think about this kind of thing, but I've been thinking about it more and more. And a lot of people are as well. So if that isn't enough reason to care, take a look at the business case. A lot more companies are considering the triple bottom line, right? It's not just about how much money you can make this quarter and satisfying your shareholders, although, that does take a big priority. But the companies that are going to win in the long run are really looking at all three aspects: people, planet, and profit. And they're all interrelated. If you treat your employees and your customers well, they're going to want to keep working for you and do good work. If you work to reduce the amount of resources that you're using, you're going to save money in the short run and in the long run. And the more companies get on board, you risk being left behind if you don't. So here's just a few quotes. You should care because your customers care. And because it's good financially and it's the right thing to do. I don't need to read these quotes, you can take a look at them. So we got that. Now let's take a look at who's on board. What companies are involved here? Sustainability reporting has been on the rise. Now we've got 86% of the S&P 500 who create sustainability reports. Now the interesting thing is, if you look at the Russell 1000 index, which is the top 1,000 largest companies, the bottom half of that index, meaning the companies that are not in the S&P 500, they've only got, say, a 34% rate. So the smaller companies are a little bit behind the large ones, but there's an opportunity to catch up, and more companies are reporting. Now I want to explain a little bit about this graph here. It comes from EcoAct consulting firm, and they took a look at the sustainability of the Dow 30. And they made an evaluation based on a bunch of different categories. They first got measurement and reporting. So they're taking a look at what types of reports that companies are putting out, how rigorous their reporting is, how long they've been doing it. They take a look at strategy and governance. Is sustainability built into the company culture? Is it being used when deciding the strategy on what directions to pursue? And then targets and reductions. Do companies have clearly defined targets for reducing their greenhouse gas emissions, for addressing water use, and a whole bunch of other factors? Right? What gets measured is what you can take action on. So you've got to measure it and you've got to have concrete goals. And then we've got engagement and innovation. Are the employees engaged? Are they all getting involved? Do they actually know what's happening from corporate regarding sustainability? And do they really want to be part of it? And then taking a look at best practice leadership. Are the leaders showing good examples? And in every single one of these categories, the information, technology, and telecom sector, which is what we're all part of here, is leading. They're ahead of these black bars are the average overall for the Dow 30, and the blue ones are for the IT sector. So when you take a look at the Dow 30, and from this EcoAct report, they did calculations on the performance of the different companies, and of the top 10, a lot of them are in electronics, led by Microsoft and Cisco, which are also both part of the Dow Jones Sustainability World Index. Let's take a look at what some of these companies are doing. For example, Microsoft, right? How are they doing it? Through carbon neutral data centers, right? We know the internet is not resource neutral. There are, I don't know how many acres of servers and how many data centers are needed to power the internet. and Microsoft is managing to make those carbon neutral. They've got 100% renewable energy at the facilities that they own. They're also working on efficient water use, working with their suppliers to help their suppliers reduce their use of water and make it done in a more efficient way. They're big on recyclable packaging. They have a goal of over 80% recyclable packaging. And then, of course, when it comes to their software, there's no packaging at all, right? I've got a subscription to Office 365. That doesn't require any packaging. It's just they're on the cloud and I've got it. But for the hardware, they're looking at the whole product life cycle. They have a generous take-back program where they're taking back their electronics and reusing parts of it, because reuse is a big part of the picture. Now HP, which wasn't listed in that previous slide because it's not part of the Dow 30, but they're still a leading company. And for my book, I interviewed Judy Glazer, who's a senior director of social and environmental responsibility at HP. And I actually invited her to come speak today, but unfortunately she couldn't make it. But in any case, I enjoyed talking with her. She led the group that built HP's supplier code of conduct. And I'll talk a little more about code of conduct later. But HP is doing some great things. They've been having a take-back program for inkjet and toner cartridges since the 90s, and they make most of those from recycled plastic. It comes both from used cartridges and also from plastic water bottles. They got a program they started a couple years ago that they're collecting water bottles from Haiti, and that provides an income stream for people there, and it also provides a clean stream of materials. They know what it is. It's not some random mix of different plastics, because they wouldn't be able to make inkjet cartridges with those. So they've got a clean stream and they're helping people out. All the HP branded paper is FSC certified, which means it comes from sustainably managed forests. And HP is also promoting faster 3D printing. So going with additive manufacturing rather than subtractive technologies that involve etching and machining is another way to reduce waste. But it's a slow process. And HP is working, they're not the only company doing this, but working to do more in parallel so it can be faster and have greater adoption. So another way to look at who's on board, take a look at ISO certification. ISO 14001. I don't know if any of you, if your companies are certified to that, or if they're listed up here. This is obviously not in no way a comprehensive list, but it's just a bunch of folks in the industry that are certified, which means they have an environmental management system and they're documenting it. Now, the ISO certification doesn't dictate exactly what has to be in that environmental management system, but it's definitely a good start. There's also a chance for more rigorous reporting. Companies have been issuing sustainability reports, but they all don't have the same level of comprehensiveness and rigor. The Global Reporting Initiative, which was founded in 1997, and I think in 2006 there were probably 1,000 companies that did reporting, and now there's almost 14,000. The GRI standards, which are the latest upgrade and went into effect last year, those require reporting in a whole bunch of different areas. Everything from governance to social responsibility, environmental, community. You have to do everything. You have to report on every single aspect. Versus if you just kind of make up your own sustainability report, you can highlight 5 things you're doing really well and not even talk about those areas where you're falling behind. But here, you got to talk about them. You got to report on them. If your hazardous waste looks worse this year than last, you got to say it. And you can go ahead and explain why, but you got to tell what's going on. Yeah, so now 82% of the world's largest 250 companies are issuing GRI reports. You may have noted the number doing sustainability reporting in the S&P 500 was higher. That's because that includes all types of sustainability reports. So as I said, the GRI standards cover a whole bunch of different things, and part of that is the environment. And for environment, they cover all these different aspects. You have to report on materials use, energy consumption, water use. If you have facilities that are in areas where there's ecosystems that are at risk, you got to report on how that affects biodiversity. Take a look at pollutants. What are you releasing into the water, air, and soil? Waste generation and disposal. If you have not complied with any local or national regulations and you've gotten fined, you got to report on that. And we talked about supply chain, which I'll talk about more a little bit later. You've got to report on what your suppliers are doing, not just what you're doing. So let's take a look at some aspects to consider. These look somewhat similar to that list from the GRI standards. So we're going to talk here about energy, water, hazardous waste, resource use, circular economy, and some about manufacturing, locations, and transportation. I'll take a look at each one of these things in turn. So one of the biggest sources of energy use in a manufacturing environment is buildings. Buildings are a big consumer of energy. And one way to reduce that is to do something like LEED certified buildings. LEED has all kinds of different regulations regarding efficient energy for HVAC, looking at lighting, landscaping, water use, comfort of the occupants. There's a whole host of different requirements. And so definitely doing LEED certified buildings is one route towards reducing your energy usage. Also, you can take a look at equipment, right? Is your equipment energy efficient? And are you using it in an efficient way? Does it automatically turn off when it's not being used? Is it possible to run things at perhaps a lower temperature and still have just as good results but save energy? And also you can take a look into putting renewables, whether that means putting a solar panel on the roof of your building or buying renewable power through credits. So one example with JSR Micro, they reduced their scope 2 emissions dramatically by switching to 50% renewables a couple of years ago. And they're not the only one, that's just one example. So when you talk about water usage, there's water that you use in your operations inside your manufacturing facility, but there's even stuff like landscaping. So you look at interior and exterior water usage. But a lot of semiconductor manufacturing uses toxic chemicals that should not be in the wastewater. So whatever wastewater is coming out of your site, you need to filter it, you need to get rid of the toxins in the effluents and not have those going into your lakes and rivers. And you can look into recycling water on site. A lot of places do that. There's a lot of opportunities to look throughout your manufacturing and hopefully do as much as you can to recycle the water, which will help in all of these. Here, I got an example from Siliconware Precision Industries. They were just doing more efficient wastewater treatment at their facilities, and they managed to reduce organic pollutants quite a bit. And there's probably even opportunities to do more. Hazardous waste. Well, I suppose the effluents in your water are certainly part of hazardous waste. There's both liquid and solid hazardous waste. What can you do to reduce the amount that you generate? Right? Treating it and disposing of it properly is important, but if you can generate less, then you've got even less of a problem. So, for example, replacing hazardous chemicals with less toxic ones or non-toxic ones. But that's not always easy, because you don't use toxic chemicals because they're toxic and you want to poison people. You use them because they're effective at doing whatever job it is you need to have done. And so it's probably a huge R&D effort to try to replace them. But there are companies that show that it can be done. And then there's some other creative things. I also mentioned here about recycling solvents in-house. So if you do need to use toxic solvents, you can recycle them, which means you're not letting them into the waterways, and you don't have to buy as much of these solvents because you're recycling them. And then there's other creative stuff like Brewer Science that's got a fuel blending process. So they take liquid and solid hazardous waste and make it into a fuel that they use in their facilities. So then they're relying on less natural gas and coal, and they're making use of this waste to power their kilns. Sounds like a great idea to me. So this is all related here, resource use and conservation. How can you use less material? and we talk about making our electronics smaller, I suppose that might be one way. But there are probably many different opportunities to use less material up front. But also ways to reuse and ways to resell processed chemicals, equipment, materials that you don't need at your facility, or maybe ones that don't meet the requirements for what you're trying to make. So one of those examples here is from TI, that they can sell unusable silicon wafers for solar panel manufacturing. They don't have the same kind of requirements that you do for making a computer chip. So there you go. And the circular economy, that's kind of the ideal, right? Where you've got two different waste streams. You've got an organic one, which has got like yard waste and food, and that ideally just returns to the soil in kind of this organic cycle. And then you've got the technical cycle, which is for metals, plastics, these kind of things that are not going to compost. And ideally that kind of stuff can be reused. It's not the linear mode where you make it, you use it, you throw it in the trash. So is it possible for a manufacturing facility to not throw any waste into the landfill? Yes. So for example, Brewer Science did just that. They promote this on their website, the zero waste to landfill, that they've been doing since 2016. I mentioned earlier the fuel blending. They recycle a whole host of different things. And they've also got a trash compactor that they use to convert non-hazardous waste to energy. So a big piece of the zero waste to landfill is taking waste and converting it into energy. And then again, you're buying less energy from the grid and you're making use of your waste. There's some other examples. Oh, all kinds of stuff can be recycled. I learned that TI is gathering hairnets and booties, right? All this stuff in the clean room that you gotta have that stuff in your clean room, and you're disposing of it. What are you all doing with it? Well, apparently it can be recycled. Who knew? Oh yeah, Synctronics. That's a company founded by Flex, that used to be called Flextronics, anyway, that takes plastic from e-waste and recycles that to make new materials and new parts. And Flextronics also has on-site smelters that collect the metals from electronics to reuse those, because e-waste is a big part of the problem. And I don't know, you might have heard in 2017, Apple made an audacious goal of removing mined metals from their iPhones. Now this was kind of generic. They didn't say, oh, we're going to do it by such and such a year, because I think they had no idea how they were going to actually accomplish this. But they've made some progress. There's a recent article that talks about, at least for one of their components, that they're using recycled rare earth metals. And these come from a third-party supplier, so they're post-industrial. They're not recovered from e-waste. But in any case, they are using some recycled material. Now, I talked about the energy required to make materials. Have you thought about all the different materials that go into a smartphone? I got this graph from Ronin 8. They're a company that's doing some really creative things to process e-waste. And I interviewed their former CEO. So what they do is they grind up circuit boards underwater, so they're not producing a whole bunch of dust. And then they use ultrasonic energy to recover the metals. And they can recover like 20 different metals. Your standard process for processing e-waste grinds up the circuit boards, not underwater, but in air, so you're releasing a whole bunch of stuff to the dust. And it recovers the gold, because the gold is really valuable. But it doesn't always recover all those other metals that could potentially be recovered because it's too expensive to do so. But I circled aluminum and cobalt, because those are materials that Apple is using from their devices. They're recycling those. They're taking cases and getting the aluminum from turned-in electronics and recycling the aluminum to use in more cases. And they're recycling the cobalt from lithium-ion batteries. Now, with those batteries, the cobalt is kind of the most valuable metal there, so that's usually the focus with battery recycling. But there's an opportunity to recycle the lithium as well. Now, historically, the price of lithium has been such that it's too expensive to recycle it. But as we make more and more and more batteries and affect the supply of lithium worldwide, the price has been going up. It's gone up quite a bit already in the last 10 years. And that means eventually there's more opportunity to recycle all the metals from batteries. So on our aspects to consider, we talk about locations. Where are your factories and fabs located? Are they close to your suppliers and your customers? Right? There was this whole trend towards offshoring, let's make everything in China, and of course there's the trade war issue, but besides that, if your customers are in China and your suppliers are in China, great, have your factory there. That's fantastic. But what about for customers in North America? It probably makes a lot of sense to have facilities closer to where the stuff is going to end up, because there's a big transportation cost of just transporting stuff around the world. And so there's ways to save on that. I mean, you think of transportation, you can even do stuff like incenting your employees to commute by transit. There's some companies that'll locate new facilities in places that are convenient to transit, so more of their employees don't have to drive their own cars to work, or they provide advantages for carpooling. There's a lot of different things you can do. So I've touched a little bit on the supply chain, but let's look a little more. The supply chain starts with the raw materials. And whether that means extracting ores from the ground, doing mining, processing fossil fuels to make plastics, wherever it starts, with sand to eventually make silicon wafers, that's where your supply chain starts. And then it goes through to all the different materials, equipment, chemicals that you buy that go into your own manufacturing facilities. So it's tempting to just kind of concentrate on those two areas I've highlighted there, which are the manufacturing, the packaging, and distribution, because that's what happens at your facility. But you got to look at the whole product life cycle. What happens when it goes to your customers? How are they using it? How are they disposing of it when they're done with it? Is it ending up in a landfill? Is there a take-back program? Are there ways to recover the materials that were used to make those products? If you're involved in design, it's not always a top consideration, but perhaps it should be, is take a look at the environment, consider it when you're considering design. Take a look at the bill of materials. Are there ways that you can use fewer materials? How efficient can you be when you're thinking about the design? And if you have all the different departments talking to each other, that might help. How about considering the recyclability? Can you use recycled content? Does it meet the purity requirements and whatever requirements that you have of your materials, or is there a way to process it so it does? And are your products recyclable when they're no longer used? And that means not just like technically could they maybe theoretically be recycled, but is there a path that's economically feasible for them to actually be recycled? And of course, toxic chemicals, is there a way to get rid of those? And it's not necessarily easy. It's not like, oh yeah, we're just going to swap out and we're going to do a water-based instead of a solvent-based process and it's easy. It's not. But if you think about it, you might come up with a solution. And taking a look at manufacturing processes. For example, additive rather than subtractive manufacturing. That's going to generally generate less waste and be more efficient. There may be different opportunities to make use of more additive methods, and it doesn't have to be a 3D printer. There's all kinds of different ways to incorporate less wasteful manufacturing processes. The big OEMs incorporate codes of conduct that their suppliers must meet. So if you want to be a preferred supplier of Intel or HP or Microsoft, you've got to meet a host of requirements. And some of them are environmental, some of them are social, in terms of, are you treating workers fairly? And companies give out awards, right? You got to have an incentive. Companies give out awards like the Intel's Suppliers. The Continuous Quality Improvement Award is their highest level of awards. They only give out a few of those a year. They've got some other levels. They give out dozens of awards. But some of the supplier codes of conduct adhere to the requirements of the Responsible Business Alliance. And this is an organization that claims to be the world's largest industry coalition dedicated to corporate social responsibility in global supply chains. And they have an extensive code of conduct that has to do with everything from how you're treating labor, right? You're not employing children, you're not employing slaves, you're giving everybody a fair wage, to environmental considerations, and a host of other things. And it just so happens that the RBA annual conference is next week in Santa Clara, and I'm going to be going. I don't know if any of the rest of you are planning on going to that, but I'm looking forward to learning. It's going to be an interesting experience. So they've got, you know, the companies there, the member companies who are coming to discuss things, and it's meant to be a forum where they've got a thing called the Chatham House Rule, which is kind of like the Vegas Rule. So it gives companies a chance to really talk about the details. So I can't afterwards tell you that company this or company that is doing such and so, but I'm going to participate in the discussions and learn. Here's an example of some of the companies that are part of the Responsible Business Alliance. Again, that's just a few of them. There are 150 companies, and new ones are coming on board all the time. So I don't know if you see your company up there, or perhaps one of your suppliers or one of your customers. And if you're part of the supply chain of one of the companies up there, you've probably got to adhere to their code of conduct. Even if you don't realize that your company's doing it, you must be. So I've mentioned a few different organizations. I'm going to provide some resources here. So I've mentioned some of these before. The Carbon Disclosure Project, it provides tools for companies that want to measure their carbon emissions. And then CSR ratings from EcoVadis, they have bronze, silver, gold ratings. You can achieve certain things and then brag about that. There's resources from the Sustainability Accounting Standards Board. They provide consulting for companies that want to step up their reporting, because it's a big endeavor to do these kind of reporting. And then we've got business associations. I already mentioned the Responsible Business Alliance. Some of these are industry specific, like the Green Electronics Council, and some are industry agnostic. The American Sustainable Business Council has members from any industry you could imagine all over the country. Oh, I just want to say the Sustainable Packaging Coalition is not about microelectronic packaging. It's about the packaging that's used to package products for shipment. Back when I was working for Advanced Packaging magazine, we would sometimes get solicitations from companies that would make cardboard boxes, and thinking we ought to talk to them. And we'd say, no, I'm sorry, that's not what we do. So for next steps, do you know where your company stands? Where is it regarding sustainability? People don't always know. Is your company ISO certified? If you've gone through the process, you probably know, because people had to ask you a whole lot of questions and you had to document every single thing you were doing. But find out. See what the corporate policy is. Is there a page on your company website that talks about sustainability or corporate social responsibility? Sometimes it's under environmental health and safety. Oh, whoops, sorry, So what role can you play? That depends on your position in the company. But maybe you can help change things. And where are you in the supply chain? Do you need to work with your suppliers, with your customers, to help them improve what they're doing? Or do you need to improve what you're doing to be able to expand your customer base? and be able to supply to those big OEMs. So I encourage you to continue the conversation. And maybe you can have a chance to change the conversation and help your company be aware that the triple bottom line is important and the environment is important. So here's some of my contact information. I also have my business cards up here. I'm working on an idea for a companion ebook to Material Value that would feature interviews from the semiconductor back-end and front-end manufacturers. And if you're interested in being interviewed for that, let me know. You can drop me an email. As I said, I've got my business cards here. You can also join my email list where I send out information about blog posts and all kinds of other different interesting information. I blog about all kinds of stuff, but a lot of it's related to materials and sustainability. And then, as Ira said, I do have my books here available for sale, and they are also available in electronic versions if you prefer that. Any questions? All right, thank you.